Hello children. In the previous session of mathematics, we were discussing on the lesson lines and angles. In the last video, we studied about the corresponding angles, studied various theorems and its proof. Today, we shall discuss on the angle sum property of a triangle. What is this angle sum of a property? Angle sum property of a triangle means you all know what is a triangle. Triangle has three angles, three vertices in it. So, the sum of all the three interior angles is equal to 180 degree. You all know this. No children, the sum of all the three angles in a triangle is always equal to 180 degree. The same thing we are going to prove under the heading Theorem 3.7. So today we are going to prove the angle sum property of a triangle. What it says, the statement of the theorem is, you have this proof as well children, you have to write this in your classwork also. It states that the sum of the angles of a triangle is 180 degree. That is the statement. And you have the figure. In figure you have the triangle PQR. The vertex of the triangle are P, Q and R. 1, 2 and 3 are the three angles of the triangle. You have one more figure. In order to prove the sum of the angles of a triangle is 180 degree, we are making some changes in the figure. That is, we are drawing construction. One more step you need to write children. I missed it. Hope you will write it. You will add one more step here after the figure, construction, and write this sentence. You write here, draw a line XY which is parallel to QR through the opposite vertex P, and hence use the proper, hence we can use the, and hence we can join, hence we can use the property of parallel lines. For this triangle, we are drawing a line XY which is parallel to the base of the triangle PQR, that is QR, passing through the vertex of one of the vertex, opposite vertex, that is P. For this Q and R, the opposite vertex is vertex P. Through the opposite vertex P, we are drawing a straight line which is XY, which is parallel to QR. What we need to prove? TPT, that is to prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. This you know to read, no children. L shape inside that number, if you write angle 1, angle 2, angle 3, like that you will read. So, angle 1 plus angle 2 plus angle 3 is 180 degree we need to prove. Next is the proof. So, in the figure, the PQR is a triangle. Draw the sentence, you will write what we wrote for the construction, the same thing. Now, the important is this part children. How we are going to prove means, we shall consider this straight line X, P and Y. XPY is a straight line. We know that. Straight line means it makes a straight angle. What is the straight angle? Equal to 180 degree. Hence children, here after drawing this line XY which is parallel to QR, along with angles 1, 2, 3 which were previously present in the triangle, we get two more new angles. They are angle 4 and angle 5. Now, near to this line, we have totally three angles, angle 4, angle 1 and angle 5. Angle 4 and angle 5 are the angles outside the triangle, whereas angle 1 is the angle which is present inside the triangle. When we consider XPY is a straight line, what are the three angles formed near that straight line means angle 4, angle 1 and angle 5. Since XPY is a straight line, it is of course making a straight angle. So, we are considering angle 4 plus angle 1 plus angle 5 is equal to 180 degree. How can we take angle 4 plus 1 plus 5 is 180 degree? We can take because XPY what we have drawn is a straight line. It is making a straight angle and straight angle is equal to 180 degree children. So, we are calling it as equation 1. But this XPY and QR are parallel. We said no. Here only draw XY such that it is parallel to QR itself we said. So here is our line XY. here is the base QR of the triangle means children. In the previous session we studied, no, for a parallel line, if at all you draw a line which touches both the lines, at some point, then those lines are called the transversal. We studied that. So for now, two parallel lines XY and QR, this PQ and PR, see these two lines are touching, both the lines XY and PQ are at some point, and that is nothing but P. So for the parallel lines XY and QR children, the sides of the triangle PQ and PR acts as the transversals, That is what is written here. But XPY is parallel to QR, PR and PQ here. PR and PQ are the transversals for these parallel lines. Means now what we get is alternate angles. Why we are proving that is, look now what we are there for. Since these two lines are parallel lines and the two sides of the triangle are acting as the transversal for those parallel lines children. Now if you look, angle 4 and angle 4 is equal to angle 2. I will show you here how. Look, to get angle 4, where is angle 4? XPQ. This is angle 4 and angle 2 means angle PQR. This angle. Angle 4 and angle 2. Are they not in Z shape? We learnt in previous session. What is the pair of angle which we get by Z? This Z shape means they are of course the alternate angles. Similarly, this is one pair. One more pair is angle 5. Where do we have angle 5? YPR. This is angle 5. PRQ. This is angle 3. So this is also Z shape. Yes, no, Z shaped pair of angles are alternate angles children. So when do you can say these two are alternate angles and they are equal? If at all you have two parallel lines and a transversal. We got that condition here. Hence, but XPY is parallel to QR and PR and PQ are the transversal. Therefore, angle 4 equals angle 2 and angle 5 equals angle 3. How can you say these two angles are equal? Pair of alternate angles. You know, in brackets, always give the reasons for whatever you write children in geometry. These two pairs make the pair of alternate angles. Hence, we can say they are equal. Now, angle 4 is equal to what? Angle 2. Angle 5 is equal to what? Angle 3. Let us substitute these values of angle 4 and angle 5 in equation 1. So, this is our equation 1. Angle 4 plus angle 1 plus angle 5 is 180 degrees, the equation 1. Now, in equation 1, in place of angle 4, substitute angle 2. So, in place of angle 4, I am substituting angle 2. Angle 1 as it is. But what is angle 5 equal to? Angle 5 is equal to angle 3. So angle 4, angle 2, angle 1 as it is. Angle 5 is equal to angle 3 is equal to 180 degree as it is. Just rearrange these angles. You get angle 1 plus angle 2 plus angle 3 is 180 degree, which was the required proof. Hence, we proved that angle 1 plus angle 2 plus angle 3 is 180 degree means the sum of all the angles of a triangle is equal to 180 degree. Hence, the proof children. This is very, very simple and very important theorem that you will have to remember. This proof is also very important children. Just draw a line which is parallel to QR. You get two more new angles. Consider all the three angles as a straight angle so that their sum will be 180 degree. Since the line drawn and the base are parallel to each other and the other two sides of a triangle are acting as the transversals, you get angle 4 equals angle 2, angle 5 equals angle 3 by, because they make the pair of alternate angles. If at all you substitute these values in our equation 1, what you get is angle 1 plus angle 2 plus angle 3 is 180 degree, which is the required proof. So this is about the theorem 3.7 children. Next you have 3.8, that no proof is given children, but one of the example problem itself they have solved as the proof. So let us now learn the theorem 3.8. You should write this theorem in the classwork children. In your textbook, they are not given in this manner. So if you want, you can copy right from the board. So next children, we shall study about the theorem 3.8. You don't have the proof for this theorem, but only statement you have. But theorem we are trying to understand by the help of an example problem here. So the statement states that if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of two interior opposite angles is the statement. If at all one of the side of the triangle is extended, then an exterior angle is formed. How? So forget about this figure for now. I will simply consider the triangle ABC. I will produce any one of the side. Better for our convenience, I will extend or produce this base PC up to some point. Okay. So I am extending produced. So if a side of a triangle is produced, so which side now? Side BC is produced to some point, says B. An angle is formed here. Angle ACD is the new angle formed. Before angle A, angle B and angle C of triangle were present. On producing one of the side, we got new angle that is called D. This is the exterior angle, children. Why exterior? It is outside the triangle. If any outside the polygons, if you have any angle, such angles are exterior angle. Inside the polygons, if you have interior angle. Here, this is exterior angle and all the three angles A, B, C are interior angles here. So, then the exterior angle so formed. Now the exterior angle is formed. How? When producing one of the side. The exterior angle so formed is equal to the sum of interior opposite angles. Means here, angle ACD is the exterior angle, children. Angle ACD is equal to angle A plus angle B, that is angle CBA plus angle BAC. These are the two interior opposite angles to the new exterior angle formed. That is what theorem 3.8 states. When one of the side of a triangle is produced, the exterior angle so formed is equal to the sum, means addition, SUM sum. Addition of, that is sum of two interior opposite angles. Suppose if you say this is X, this is Y and this exterior angle formed as angle Z, children. Angle Z is angle X plus angle Y. Andre exterior angle is equal to the sum of interior opposite angles. That is what theorem 3.8 states. In order to understand this in a better way, what we shall do is consider an example problem. So in this example problem, the question is, this triangle PQR is given. QT is drawn perpendicular to the side PR of the triangle and PS is drawn such that angle PQR is 40 degree and angle SPR is 30 degree, and since QT is perpendicular to the side PR, angle T is clearly 90 degree. Here you have angles X and angle Y. R is X, S is Y. So we need to find out what are these angles X and Y, children. So how do we do is, in the figure QT is perpendicular to PR. Yes, therefore, and also given angle TQR, this angle is 40 degree is been given and angle SPR is 30 degree is given. We need to find, see, angle X equals angle Y equals question mark, means we need to find out what are these angles X, angle X and angle Y. In order to do that, children, where are these angle X and Y present? In this part. Yes, no? X and Y are present here, means we shall consider this triangle only for time being. This triangle, I have highlighted it. Hope you can see. As I said you in the last class, I cannot use color chalk, children. It's of no use. No color difference can be seen in the video. Hence, this highlighted part is a triangle. Which what triangle it is? Triangle T, Q and R. Now, we got triangle TQR. Previously in theorem 3.7, we studied about the angle sum property of a triangle. What it says? The sum of all the three angles of a triangle is 180 degree. Let us us make use of that concept here. In triangle TQR, angle T plus angle Q plus angle R is 180 degree. How can you say? In the bracket I have given there is an angle sum property. Now, in this triangle TQR, we know what is angle T. It is 90 degree. Why 90 degree? They have not mentioned. Though I am taking T 90 degree. Why? QT is perpendicular to side PR. Perpendicular under 90 degree. Alva? So, angle T 90 degree I will substitute in place of angle Q. They have only given us angle Q is 40 degree. So, substitute Q is 40 degree. And angle R is what? They have labeled as X. That is what we are finding here. Angle R is labeled as X. So, I am replacing angle R by the letter X. That's all. T 90 degree I am substituting. Angle Q given 40 degree I am substituting. Angle R is labeled as X. So, I am writing X is equal to 180 degree as it is now. 90 plus 40, 130 degree plus angle X is equal to 180 degree. What is angle X? 180 plus 30. When you send it to other side, it becomes minus 30. 180 minus 130. Clearly, we got, children, angle X is equal to 50 degree. Hence, we got this angle X to be equal to 50 degree. So, we find out X. Still, we have to find out what is angle Y as well. To do that, let us consider this angle Y. We need to find out what is angle Y. Just now, I showed you, no children, one triangle and producing one of this side the statement. To do that, I will consider this triangle PSR. Which triangle? This triangle. Can you see? This triangle, this you forget. Triangle PSR I am considering now. I am producing the base of the triangle PSR, that is side SR, and produce to some length. That gives me a new exterior angle which is equal to Y, which is labeled as Y. This angle they have given as 30 degree and this angle X just now we find it out to be 50 degree. Now in this triangle PSR, children, we know angle P is 30 degree, angle R is 50 degree, but our aim is to find what is angle S or angle Y is question mark. So using the statement of theorem 3.8, children, angle Y is the exterior angle formed or producing the side SR or RS of the triangle PSR. So, the exterior angle is equal to sum of interior opposite angles. Which are the interior opposite angles for angle Y? Of course, angle P and angle R. Hence, we can write angle Y is angle SPR plus angle X. I am writing Y because it is angle R. If you want one more step, you can write if it is confusing. It is SPR plus PRS. Next step, you can substitute. Your SPR we don't know. Sorry, SPR we know 3360 andre angle PRS is replaced by angle X. Why? Angle R is represented by angle X, labeled as X. So SPR plus X is Y, angle Y. Y is equal to SPR, they have only given us 30 degree, so substitute. Angle X just now we find it out as 50 degree. So angle Y is 30 plus 50 andre, which is equal to 80 degree, children. So this is 30 degree, this is 50 degree, means this angle Y is clearly 80 degree. So did we prove theorem 3.8 statement? That is, the exterior angle is equal to the sum of interior opposite angles. Which are the interior opposite angles? P and R. How much is P? 30 degree. How much is R or X? 50 degree. 30 plus 50, 80 degree. Which is also equal to angle Y, which is the exterior angle. So this is about the theorem 3.8 statement and one of the example problem. With this backgrounds and concept, children, now we shall solve the last exercise of this lesson, that is exercise 3.3.